Hi there. This video is going to look at a way of writing numbers, especially if the numbers are really large or really small numbers. In New Zealand, this way is called standard form, but in other countries it is also known as scientific notation. If we look at this first number here, 4.052 times 10 to the power of 6, that number is written in standard form. Here is the number written in ordinary form. So this number 4,052,000 can be written like this. With standard form there are two parts. We have this part here, which is a number between 1 and 10. So that number, if we call that number A, it's going to be greater than or equal to 1, but less than 10. It can be a decimal. And then the second part of the number written in standard form is a power of 10. So if you look at the ordinary form of that number, what you do is you take or you find the first non-zero digit, which is 4. And so you write 4 and then just place a decimal point to the right and then write all the rest of the non-zero digits. So we need to include that 0 there. And then we work out what power of 10 do we need to multiply 4.052 by in order to get back our original number. So if we multiply 4.052 by 10 to the power of 1, we get 40.52. If we multiply 4.052 by 10 to the power of 2, which is 100, we'll get 405.2. So what power of 10 must this be in order to get back to our original number? So it's going to be, and the way you can sort of do this is wherever you're going to place that decimal point, which is going to be there, we can just count our powers of 10 until we get to the end of the number. So it'll be 1, 2, 3, 4, 5, 6. So I need to multiply 4.052 by 10 to the power of 6. Right, let's look at another example. We've got the speed of light here. It's approximately 300 million meters per second. So if we were to write that in standard form, our first part of standard form is a number between 1 and 10. Identify your first non-zero digit, which is 3. There aren't any other non-zero digits, so we're just going to keep that number as 3. So 3 times 10 to the power of, so if the decimal point was there, 1, 2, 3, 4, 5, 6, 7, 8. So 3 times 10 to the power of 8 is 300 million written in standard form. So we can use standard form to do calculations. How far would light travel in 2 minutes? So 3 times 10 to the power of 8 meters per second is the speed of light. We need to multiply that by 2 minutes in seconds. So 3 times 10 to the power 8 meters per second times 120 seconds. And what does that give us? Okay, using our calculator, we're going to use the button here, EXP button, which stands for exponent. When you press that button, you're telling the calculator to input a power of 10. So to input 3 by 10 to the power of 8, type in 3. You don't need to type in the multiplication sign. All you do is you just press the EXP button and an E should appear on your screen. So what you've just entered into the calculator is 3 times 10 to the power of, now the calculator is just waiting for you to enter the power. So in this case it's 8, and then we're just multiplying that by 120. We get 3.6, and just looking at the calculator again, E means times 10 to the power of, and that positive 10 there is the actual power. So 3.6 times 10 to the power of positive 10, which is just 10. And just a note about your calculator, you can change the setup. So if you go Shift Menu and then just scroll down to Display. So at the moment it's in normal display. We can, if we select F2, which is scientific significant figures, how many significant figures do you want the first part of the standard form way of writing numbers to be written to. If we say 3, execute, just exit out of there, and if I go just pressing EXE to give me that number again, you can see it comes up with 3.60. So that's because we set the calculator to be fixed at 3, it means it's going to give us 3 significant figures. Okay, so let's have a look at another example here. The approximate volume of Earth is 1.08321 by 10 to the 12 cubic kilometers. And the volume of Mars is written there as well. What percentage of Earth's volume is Mars? So you may know that Earth, of course, is much larger than Mars, but if you look at the powers here, we've got 10 to the power of 12 here, 10 to the power of 11. So generally, as long as these numbers are between, so that number there are between 1 and 10, then whichever power is higher will be the larger number. The volume of Earth, if I were to convert this number such that it would have the same power of 10 as Mars, it would look like this. 0.8321 times 10 to the power of 11. Okay, so all I've done is I've taken out a power of 10 from this 10 to the power of 12, multiplied it by 1.08321 to give me this number here, which is not in standard form, but it allows us to compare the relative sizes of Earth and Mars. So 10.8321 is larger than 1.6318. So Earth is bigger. So what percentage of Earth's volume is Mars? So what we're doing is we're looking at the volume of Mars divided by the volume of Earth, and then we're going to multiply that by 100 to give us a percentage. So volume of Mars is 1.6318 by 10 to the 11 divided by 1.08321 by 10 to the 12, and then we need to multiply that by 100. Okay, so entering these numbers in standard form, 1.6318 exponent 11 divided by 1.08321 exponent 12. So that gives us 1.51 times 10 to the, let's just write that down, 1.51 times 10 to the, and you will notice that we have a negative power here, negative 0.1, which is the same as just -1. And what that means is when you get a negative power, you end up dividing by 10. So 10 to the -1 is the same as 1/10, or 1 over 10 to the power of 1. So this number ends up being 0.151. But of course we're going to multiply that by 100 to give us the percentage. So it's about 15.1%. So the volume of Mars is about 15% of the volume of Earth. Okay, a couple more examples here. So we're just dealing with really large numbers at the moment. The world population is estimated at about 7.4 billion people. So let's write this in standard form. So our number between 1 and 10 is 7.4 times what power? So if the decimal point was there, we'd need to multiply it by 1, 2, 3, 4, 5, 6, 7, 8, 9 powers of 10. So 7.4 times 10 to the power of 9 is the same as 74 billion. If over the next 25 years this amount increases by 40%, what would the new world population be? So we're increasing by 40%. So we're going to multiply that by 0.4. .4 exponent 9 times 0.4 equals 2.96 times 10 to the power of 9. And now we're going to add that to our original population. So 7.4 by 10 to the power of 9 plus, because it's increased by 40%, 2.96 times 10 to the power of 9. 7.4 exponent 9 plus 2.96 exponent 9 gives us 1.04 times 10 to the 10. 1.04 times 10 to the power of 10. And that's standard form for really large numbers. Might want to check out the next video on standard form, looking at really small numbers.